Okay, so the lesson is now being recorded. All right, guys, so we are in week 2 of this final 6 weeks, and we are rapidly approaching the end. This is the first week in May, the last month of the school year. Okay, so on today, we are continuing our topic into electric circuits. Remember, we started this on last week. But what we're doing today, we are going a little bit more detail electrical circuits, but we're going to kind of get into more detail with the mathematics behind electrical circuits. Remember on last week, we covered the concepts, and you guys did that assignment in Schoology. So let me go ahead and share my screen. Okay. Um, if you guys are at your computer and you are logged into Schoology, you should already be able to see the assignment because it is already open for you all. So we're in the first period. And of course, off to the side here, you guys should see the assignment. The name of the assignment is called Ohm's Law. So it's actually in the folder for today. So if you click on the Materials tab, uh, scroll to the folder that says Final 6 Weeks. Okay. And of course, today is May the 3rd, and it is a Monday. Okay, so the assignment is already open, ready for you guys to get started on it. There are about 15 questions in the assignment. A lot of these questions we're going to do together as a class. I'm going to walk you guys through the mathematics, and then we're going to do a lot of these questions together as a class just to give you guys a feel for how to do the assignment. Okay, so this just get into the mathematics behind electrical circuits. And the mathematical equation that you guys are going to need to use is what is known as Ohm's law. And then in a moment, I'm going to write down what that equation is as soon as I discuss a few things. Okay, so that is the goal for today. To discuss this equation, which is known as Ohm's law, and then we're going to get started on the assignment together, and then I'm going to let you guys finish the rest on your own. Okay, so everybody got that? All right, so uh, let me remind you guys of what an electric circuit looks like before we get started with the mathematics of electric circuits. Okay, so imagine that you have some sort of battery, okay, and obviously all batteries have a negative end and a positive end. And imagine that you connect a copper wire to that battery. Okay, if you connect a copper wire to that battery, then you created an electrical circuit. There's going to be a flow of electrons from the negative end toward the positive end. Why do electrons flow away from the negative end? Well, because light charges repel each other. Why do electrons flow toward the positive end? Well, that's easy. That's because opposite charges attract each other, right? So the negative charges on the electrons are attracted to the positive end of the battery, and that's what creates the flow in the circuit. Okay. Um, and of course, a copper wire is an excellent conductor, right? Those electrons are free to move around. So there's electrons that are distributed throughout the copper wire, and of course, those electrons they flow like this. Okay, so in the electric circuit, they flow from the negative end toward the positive end. And of course, even though I have one electron being represented here, in reality, think of millions of electrons flowing through this circuit, kind of like what you see here. Okay, so hopefully that makes sense. All right, so all right, so now going back to Schoology. Now that you guys have an excellent understanding of how an electrical circuit looks like, let us discuss a few terms. Okay. So for today, there are 3 terms that you guys need to be aware of. And let me write down these 3 terms. Okay. three terms are voltage, current, and resistance. We already talked a little bit about resistance last week. Let me write that down. Voltage, current, and resistance. These are the three terms you guys need to know. Okay. So now, as far as your units are concerned, um, uh, whenever you're writing out your answers for these three terms, because you're going to be solving for them, you guys need to be able to know what your units are. So, let me write this down. So, for voltage, the units, you just write a big V for your units, which just stands for volts. Okay. Guys, for current, you're going to write amps, or just A for amps. And of course, for resistance, the unit for resistance is the ohm. So you will write ohms for your units for resistance. Okay. So in just a moment, I'm going to explain what each of these terms mean. And then I'm going to give you guys an equation that relates to these three terms. And then we're going to get started on the assignment. Okay. So just so we're clear, so guys, anytime you have a battery, all batteries have a certain voltage that is associated with them. So for example, you guys might have seen a battery that has this listed on it, 12 volts. Okay. So guys, what that means is the voltage, think of this as being the think of the voltage as supplying the potential energy for the circuit. Okay, that's what voltage is. It's well, technically it just means potential difference, but just imagine it's what's responsible for supplying the potential energy of the circuit. In other words, the battery is what's responsible for pushing these electrons along through the battery. So the battery acts as a pump, to pump the electrons from this end to that end, creating a potential difference. And then of course, the electrons are going to flow through the copper wire. So that's what voltage is. Okay. Think of voltage as being the potential energy supplied by the battery. What about current? Okay. So, well, current just means the rate of charge flow. So basically, current refers to the amount of electrons flowing in the circuit in any given unit of time. So current just refers to the rate of charge flow. Imagine a river, and a river has a current. You guys can imagine a river with a high current. Obviously, a lot of water is going to be sweeping through the river in any given unit of time. But a river that has a low current, a small amount of water is going to be sweeping through the river in any given unit of time. So think of current as being the rate of charge flow. And lastly, resistance is exactly what it sounds like. Resistance is exactly what it sounds like. A resistor is a device that slows the flow of current, right? So they actually put resistors in circuits to control its flow, right? Because a resistor can slow down electrical current. So if you can slow down electrical current to whatever it is that you want to, for the benefit of that circuit, that will require a particular type of resistor. Okay, now with that said, guys, all of these terms can be related to each other using a very simple equation. And let me write down what that equation is. The equation that relates all these terms is what is known as Ohm's law. So Ohm's law says that current is mathematically equal to voltage divided by resistance. And yeah, guys, every time you see an I in this class, we use the symbol I to represent electric current. So I is for electric current. Okay. So this is the most important thing that you guys need to know for today is Ohm's law. Ohm's law says that current is mathematically equal to the voltage of the battery divided by the resistance of the circuit. Okay, so everybody got that? So one more thing that I want to discuss before we get to that assignment is some important facts. So according to this equation basically tells us that voltage and current are directly proportional to each other. What that means is that you have a circuit, as voltage increases, then the current increases. As voltage decreases, then the current decreases, right? And that makes sense, right? Because if you have a battery with a much greater supply of energy, obviously that battery is going to produce a greater current. Okay. Now, this equation also says that resistance and current are inversely proportional. What that means is that as resistance goes up, current goes down. And as resistance goes down, current goes up. And that makes sense, guys, because if you have a circuit and you increase the resistance of that circuit, obviously the current is going to decrease, right? Because resistance, the more resistance, the smaller the rate of charge flow. So let me write that down. Okay. So as voltage increases, then current increases. As voltage decreases, then current decreases. Okay. And as resistance increases, then current decreases. As resistance decreases, then current increases. Okay, so these are the important facts you guys need to know in order to do that assignment. Okay, so any questions before we do parts of the assignment together? Any questions? All right, so with that said, let us go to the assignment right here. So guys, if you're already at your computer, open this up with me, and we're going to go ahead and get started. So, okay. So again, I'm just going to do a few of these with you guys. I want to start with the mathematical questions first. Okay, so I'm going to start with the mathematical questions first. Let me see. Okay, guys, go to this question right here, where it says, how much current does a 9-volt battery push through a 3 ohm resistor? So go. go to this question right here. Okay. So, how much current does a 9-volt battery push through a 3 ohm resistor? Okay, so guys, remember what I told you. Current is equal to voltage divided by resistance. So let's write that down. So if current is equal to voltage divided by resistance, okay, what is our current when we have a 9-volt battery and we have a 3 ohm resistor? Okay, so what is your answer here? So y'all should know how to do this. 9 divided by 3. That's easy. That is equal to 3 amps. So here our current is 3 amps. Okay. Hopefully that makes sense, right? So you have a 9-volt battery, and you have a 3 ohm resistor. So you just do 9 divided by 3 to get 3 amps. Any questions there for me? Anyone? All right, let's keep going. Guys, let us look at this question right here. This question right here says a 10-volt battery produces 18.5 amps in the circuit. How much resistance is in the circuit? Okay, so here we're solving for resistance. So just so you guys know, whenever you're solving for resistance, this is what you guys will need to do. If I take this equation here and rearranged it, so we already know that current is equal to voltage divided by resistance, right? Okay. So if I take this equation and rearrange it and solve for resistance, I will get this. Resistance is equal to voltage divided by current. Okay. And of course, I can also take this that equation at the top and I can rearrange it and I can solve for voltage, where voltage is equal to current times resistance. Okay. All right, guys, so keep that in mind. Whenever you're working on the mathematical, the remainder of the mathematical problems by yourselves, you're going to either use one of these 3 equations. Okay. So with that said, so here it is asking for the resistance, right? They tell us our battery is 10 volts and our current is 18 amps. So since we're looking for resistance, we're going to say resistance is equal to voltage divided by current. Okay. So resistance is equal to voltage divided by current. Okay. So our voltage is 10 volts. Our current is 18.5 amps. Okay. So in order to do the math there, let's see what we get. So 10 volts divided by 18.5 amps. Okay, so guys, when I put that in my calculator, 10 divided by 18.5, what I got a value of 0.54 ohms for my resistance. Okay. Make sense, guys? All right, let's keep going. Again, I'm gonna do enough of these so you guys can do the rest by yourselves. Let's do one more math problem. Let's look at this one right here. This question right here says a 6 ohm resistor has 8.5 amps running through it. Find the battery's voltage. Okay, so guys, here, since we're looking for volts, that means we need to use this equation right here. Voltage is equal to current times resistance. Let's come over here. I'm gonna write this equation down. So voltage is equal to current times resistance. Okay. So if we know the current is 8.4 amps, we know the resistance is 6 ohms, so we just do the math there. So 8.4 So that gives me 50.4 volts. 50.4 volts. Okay. So y'all got that? All right. So let's keep going. Um, let me see. I want to do some of the diagram questions with you guys. Let me see. Let me go to those. I think there's like a few of those. Okay, so guys, so we have two diagrams here where we have two batteries right next to each other. The question is, if we assembled our batteries in this way, will this work? In other words, will we get a flow of current through the electric circuit? Um, what do you guys think? Well, guys, remember what I said last week. Whenever you guys see symbols like this in a circuit and they represent a battery, remember the longer end is a negative. Well, the longer line is the negative end, and the shorter line is the positive end. Guys, if you remember, anytime you have an electrical circuit, um, let's say you have a flashlight and you put your batteries in a flashlight. Guys, it should be obvious to y'all that whenever you're stacking your batteries in your flashlight, you have to stack them like this, right? In order for your flashlight to work, you have to stack your battery like this, right? Because no, this is the negative end, this is the positive end. That's the negative end, that's the positive end, right? Because that's the only way that you're going to get a charge flow through the circuit. If you stack your batteries like this. So if you stack your batteries like this, then clearly you're going to get a rate of charge flow um, through the two batteries. Okay. So in other words, here the positive end has to be connected to the negative end. But guys, look closely at this diagram right here. Is that how this is set up? Yes or no? What do y'all think? Is this diagram set up to where the negative end is connected to the positive end when you connect the two batteries? Yes or no? Anyone want to tell me in the chat box? Okay, you are correct. Someone sent me a private response. The answer to the question is no. This will not work because notice how um, um, this positive end right here is connected to that positive end. So it's not negative connected to positive. So this will not work. So you are right. Thank you. Okay. But what about this situation right here? Will this work? Well, it should be obvious to you guys because notice this end right here is positive and that end right there is negative. So now the negative end is connected to the positive end. So yes, this will work. And so the total voltage of this battery will be 12 volts, right? Because you're combining two batteries. 6 plus 6 gives me 12 volts, right? So hopefully that makes sense. Okay. And guys, it should be obvious to you guys why this situation won't work because it's kind of like putting two batteries in your flashlight like this. Like if you put two batteries in your flashlight and you put them like this, uh, then there's not going to be a rate of charge flow, and so your flashlight won't even come on if you put your batteries in your flashlight like that, right? Because that is not a complete circuit. Okay. Okay, guys, look at this one right here where it says match the words with its description. Okay, so voltage. What is voltage? Okay, remember what I said? Voltage represents basically the potential energy or the potential difference of the battery. So the voltage is what's responsible for pushing electrons through the circuits, right? Because you have that potential energy supplied by the battery, that's responsible for pushing electrons through the circuit. Okay. Current. What is current? It's the amount of electricity flowing in a circuit in a given unit of time. Okay. What about resistance? Resistance slows electricity down in a circuit. Okay. All right, and of course, the rest of these you're gonna, do by yourselves. Any questions so far? I'm almost done. Okay. Do batteries add or reduce voltage? Okay, we already talked about this. Batteries is responsible for giving potential energy to your circuit. So in other words, batteries increase voltage because that's what voltage is potential difference. So batteries add voltage. Okay. Um, So look at this right here. Look at this question right here. It says, if you increase resistance, what decreases? Guys, in order to answer these questions right here, you just go to this this situation right here that we talked about. So it says as resistance is increased, what decreases? Well, guys, look here. Look what it says. If you increase resistance, then current decreases. So you decrease current. Okay. And there are a few of these like this, a few problems like this. Where, for example, look at this one. It says, if you increase voltage, what increases? Well, go here. So as voltage increases, then current increases. Okay. And there are several problems like this or similar to this. For example, here it says, if current increased, what decreased? Well, go back to this right here. So you can see then, you can clearly see that if current increased, okay, you guys clearly see. So if current increased, then that meant that if current increased, then that means that clearly that resistance decreased because it asks what decrease, right? So that we see that here. If current increased, that means resistance had to decrease. So that would be that right there. Okay, so I want you guys to do the rest by yourselves. Again, just use these principles here to answer, the remainder of those questions that look like that. Okay, and I think I'm gonna stop here. Are there any final questions before I let you guys go? If you guys have not filled out the attendance form, please go ahead and do so at this time. If there are no immediate questions for me at the moment, you guys are free to go. Enjoy the rest of your day, everyone.